Hello, ladies and gentlemen. Welcome to this closing plenary session. As you all know, the future is crucial. The future are the young people. The future are students, the students of today who will shape, let's say, the industry of tomorrow. So, together with the jury, we had a long debate. And therefore, I would like to thank them and invite them on stage to come and take a seat on the podium. All the members of the jury, please. So to give you a little bit of background, I introduced at the beginning, at the opening plenary session, that there are student posters. Many students made proposals. We made already a pre-selection, and we, showed it at the beginning at the entrance of the exhibition room. So all of you have had the chance to have a look. And I can tell you there are very interesting ideas, very strong studies, and it's really, really very encouraging for the future. So, together with the jury, we had a long debate. We had some difficult discussions. We had more time than anticipated for. But we came, in the end, to a conclusion. And so we are more than happy to present to you the conclusion of the debate, of the deliberation that we have been able to do. And therefore, I would like to invite on stage Frédéric Charon from the SIA for the third prize to present why the SIA is, giving a third prize, is adhering so much attention to the students, and then we can announce the winner of the third prize.
Okay, so 2 days of innovation. CAR is also a passion. We mix them together in a special show that we will that we announced today because it's not widespread. During the Mondial, the Paris Auto Show, we will have a show, an exhibit of 19 vehicles and their technologies that they have paved 120 years of innovation, 90 years of Paris Auto Show. You never stop progress. So I'm very proud. We are organizing this show together with the PFA. And there will be a second phase that will be dedicated to the next technologies of the future. And we will, as a prize, have the pleasure to welcome the team of the winning the third prize for a private visit with experts explaining all the technologies and the stories of the car, especially for you during the Paris Auto Show week, third week of October. Oh, pardon.
Congratulations for the work. Please come on stage.
Team on stage. The team.
There you are. Excellent, excellent. It is an excellent work on
Thank you so much.
Yeah, excellent work on new electrical motors, which are absolutely key for the future of our EV vehicles. And so, yes, it was extremely interesting to see that new study.
Thank
Congratulations.
you so much. Thank you.
You can come and then... Okay, congratulations. Nice work. And then we come to the second prize. For the second prize, again, we had a long debate, really a tough debate. Here I would like to invite on stage here Yutak to come and present, let's say, the topic That will be given as the prize, and the reason why UTech is sponsoring students.
Hello, everyone. So I am Mathieu Lamarlière from UTech, and I'm very, very proud to offer this second prize to the student here today. You know, for UTech, we really will to promote and encourage the student project. We have, for instance, the UTech Challenge, which is a competition regarding the vehicle and system conception regarding the new mobility, the mobility of tomorrow, for autonomous vehicle or increasing range functionalities, for instance. And it's open to students worldwide, so maybe students you may want to participate next year. So I'm very proud to offer some tickets to the centenary of the UTech Lina Smolery centenary in October.
Please come on stage. As a matter of fact, what we see in the industry that there is a big change. We need to look a lot further than only, let's say, the development of the systems as the powertrain itself, but also the complete materials, where the materials come from, how they can be recycled, so the full life cycle. And that is an excellent topic, so congratulations for your work. And then finally, suspense. The winner is, the prize will be given by Imitech. And again, I would like to invite on stage just the explanation of Imitech as why Imitech is sponsoring this and why it's so important for you.
Ladies and gentlemen, dear students, I'm Stéphane Lasso, CEO of Imitech Group. It's an honor for me to offer the first prize of ISIA Powertrain 2024 Student Challenge on behalf of Imitech Group. At Imitech Group, we believe in the power of young talent like you. Last year, we welcomed more than 60 apprentices and interns, and it is part of my personal history because I began in Imitech as an intern in 1999. We value at Imitech youth and innovation, and that's why it's very important for me to support and encourage students like you today. Now the job search period is approaching for you. Not at Imitech, we have many job opportunities on more than 50 open positions, so I want you to apply. Don't hesitate to send me your resume, and maybe just like me, one day you will be CEO of Imitech. Congratulations to the winner of the Student Challenge 2024, and I hope you will enjoy yourself on the track with this driving experience.
IFP, Energy Nouvelle. Advanced Energy Management System for hydrogen fuel cell electric vehicles. Congratulations. Also this year, a very big team from IFP. So very good, very good. It was a work which was extremely well prepared, a good concept, object description, the way of making the study was done very well. I'm not going to present your project because you will have the opportunity to do that in 5 minutes right after. So congratulations for winning. And let's make a picture first, and then one of you will have the opportunity, or all of you will have the opportunity to have a short introduction of your project. Congratulations. Or you can put them on the table over there if you want. Okay, so you have about 5 minutes to just introduce. Unfortunately, due to time constraints, we will not have questions, but we already challenged you with many questions from the jury before, so I guess you're totally exhausted from that point already. Anyway, people can find you afterwards, but here is the opportunity for you to present. And I have a small surprise, an additional surprise. I spoke to the panel leader of the VIP panel later on, and one of you will have the opportunity to ask a question directly on stage to the panelists later on in the afternoon. There is still time. You still have, let's say, almost 1 hour to prepare, but please start thinking about that afterwards.
Okay, thank you.
Okay, good. So, please. Ça, c'est votre poster. Introduisez-le en 5 minutes.
Okay. So, we all know that the world today is passing through some difficulties regarding the CO2 emissions. So fuel cell electric vehicles are a very good solution to tackle this problem, but there is still some difficulties regarding the availability of green hydrogen in our world currently. So to avoid this, to get around this, we developed an energy management system specifically designed for fuel cell electric vehicles to minimize the fuel consumption. So this project was made in partnership with Green GT and Helico Trucks, so thank you. And this project is very nice because it not only works for the Helico Trucks, but it's fully tunable, so you can apply every driving cycle and every kind of fuel cell electric powertrain to it, and computate its power split between the battery and the fuel cell for the minimized fuel consumption.
So our strategy was an offline strategy. So we have a driving cycle, slope, and we chose the type of vehicle. Thanks to that, and thanks to the fuel cell model, I will not explain here because we don't have so many times. We have the power request, and thanks to the power request and the characteristic of vehicle, the energy management system that we develop, just sharing the power between the fuel cell and the battery. And for the energy management system.
So inside the energy management system, we have implemented an algorithm that is an optimization function called the Pontryagin maximum principle. So for all the optimization problem, we have to define a control objective function. In our case, it was to minimize the integral in time of the mass weight of the hydrogen. And then we have also to define what was the degree of freedom of our optimization problem. In our case, regarding about all the equation of the problem, we decide to go with the power of the fuel cell. So it means that we have the power balance that my team explained before. So we have the power split between the battery power and the fuel cell power. So the power balance is this equation. Then we have also the shock rate that is a function, of course, of the shock and the the power of the fuel cell. Then we have also some boundary condition for any optimization problem. And then we have implemented a Hamiltonian function, so it's equivalent to a cost function, in order to be sure to compute what was the optimal point. So we have to link it with a cost. So if we are looking at the minimum cost, of course, will be the optimal point. If we are looking on the flowchart of the algorithm, we start with the input, which is the cycle. We compute the power request from the vehicle dynamics. Then we compute the cost for each candidate. So this is the U loop that you can see here. Then if it's the minimized, we know that it's the optimized point, the optimal power split. Then we implement it on the time step. Once all the time step of the driving cycle is finished, we have to be sure that we have the same state of charge as the beginning. So the final shock should be equal to the initial shock. And then we implement the S loop. So the S loop is to have to know what is the cost of the power coming from the battery over the cost coming from the fuel cell. And we have implemented also the shock sustaining. It's the approach using a PID. And this is the approach that is using inside the helico trucks. And it was only for comparison purpose.
Yeah, in our case, helico was using their trucks in the Lyons area. So we use a driving cycle, a mix of urban and highway paths. Thanks to that, we've got a lot of good results thanks to our algorithm by reducing the consumption by a quarter and increasing also the range. And we maximize the amount of time of where the fuel cell is at its maximum efficiency.
So applying it to our study case, that it was the helico truck, we managed to get these results. Here you can see the blue line is the shock sustaining strategy that they use today. And the PMP optimizes the orange one, that is our strategy for that driving cycle and that vehicle. And you can see clearly a reduction, especially on high power requests a period of time. And at the end, we managed to get with our, we expect to get with our algorithm a reduction in 24% of hydrogen consumption using our solution. That it's translated into an increase in the range of 87 kilometers, so it's very promising. And at the end, the next stage of this project is actually implement our system in the ECU of the helico trucks to test it in real-world scenarios, and that's it. So, you wanna? Yeah. Thank you.
Just a quick word to say thank you for having us on stage, and thank you for having us to allow to share our work through this poster. And also a big thank you to all the classmates that support us during this period. Thank you for the teacher teams, and thank you for the Martin, which is our supervisor, Martin Checo Perez from Green GT, which is not here, unfortunately. A big thank you.
Congratulations. Excellent. Well done. Well done. And I would even ask for a round of applause for all the students, because all the posters were at extremely high quality. Everybody really gave a lot. Very interesting ideas, and we are really looking forward to the next posters and the next developments that you can do, but also the other students can do on their posters.
Thank you.